APR over M raised to the power M. So therefore, you have to enter the APR itself. And the APR itself is 18. How do I get that? It's 1.5 times the 12. Do you get it? Because if you enter 1.5 for the num, the answer will be wrong.
Exactly, that's my question.
That's right.
So that means I have to divide 1.5 divided by 12.
No, you have to use 18, i.e. the 1.5 times 12. It is times 12. You have to start with the APR. Because the 1.5% is the APR divided by 12. Do you understand that? So therefore, you have to be careful if you want to use the icon function. Because num is the APR. It is not the APR over M. Do you understand my point? Yeah. Do you get it? Do you get it? Got it? Okay. What is it?
You said num is APR?
Yeah, no, the num is the APR. But is 1.5 the APR in this case? Is it? Is 1.5 here the APR?
No.
No. It is the APR divided by 12. You see the problem? And yet we want APR in that function.
So that means we have to reverse it.
That's right. So therefore, if you want to use that function, then you have to know that the APR is really 18, which is really 1.5 times 12. And then if you do it that way, then you get the right answer. Yeah. Thank you for your question. Is that good? Next. So I'm glad that we still did it, yeah? Because now you know, when I say show your work, I must see the formula with the values in them, right? Next. Let me read it. If you borrow $200,000 and agree to repay the loan over 15 years with monthly payments at an interest rate of 9%, what will your monthly payment be? I think we've done that before. So again, payment is such that the loan of 200,000, right, is the present value of all payments, right? 1 minus 1 over 1 plus 0.09 divided by 12, and then how many years? 15 years times 12 over 0.09 divided by 12. Does that make sense? And then we solve for PMT using the financial calculator. What is N? Well, 15 times 12 will be my N. For my I would take 9 divided by 12. And then for my payment, well, that's what we're looking for. Present value here is going to be 200,000. 0 for future value. And then I compute what? Payment. And of course the payment will be a negative number here. And I think if we do this, the payment is going to be I think the answer is 2028. Is that correct? That implies that payment is 2028 point what point? 53. That's the answer. So do you have any questions? No, okay. Who wants to read 34? Actually, 34 is going to be a very important problem for Monday's exam.
Suppose your uncle is 40 and has a plan to retire at age 60, but his fortune teller told him that he will live for 40 more years. If he would like to have a steady income of $150,000 per year after his retirement, and the interest rate will be 8% compounded yearly at that time, how much must he set aside each year till his retirement to be able to achieve his goal, if the interest rate is now 6% compounded yearly?
Okay. So do you know how to do this now? Actually, this one we want to do it, right?
Mm-hmm.
This one we definitely want to do it, because I think I need to show you a timeline. With a timeline, students can understand exactly what's going on, right?
Mm-hmm.
So let's see, this is to that, in terms of T, and then in terms of age, 40, right? And then you are going to retire at age 60, which of course here means period 20. Okay, right?
Oh, because you're currently 40, yeah.
Because you're currently 40. And then here it says the fortune teller says that,
You're gonna live
well, it tells him that he will live for another
40 more years.
40 years, as of today, right? Because he was told that today,
Oh,
right? So
Sure.
that means that he's gonna live until he's what?
80. Oh, that's tricky.
I know. But of course, between here and there, it's 20. Do you agree?
Uh-huh. Oh, I would have messed that up.
Yeah, I know. And then he wants to receive a steady income of $150,000 per year during retirement, right? Is that what it says?
Mm-hmm.
Okay. And here, because we do not specify, we are going to make the assumption that the first 150K is received at the end of the period during retirement.
Oh,
Does that make sense?
yes.
So therefore, obviously retirement is gonna start right here, right? So therefore, the first one, 150K, all the way to what? 20 years. You know what the question is? The question is this: how much does your uncle need to put aside each year, starting today, so as to achieve his retirement goal, right? So that how much, so therefore, in period one, what must be the PMT? What must be the PMT? What must be this PMT? All the way to what? All the way to retirement. Year 20. So that he will have enough money to support that 150K annuity for 40 years, or be 20 years. Does that make sense?
Mm-hmm.
So we have to start out with the 150 at the end in order to calculate.
Very good,
payments
because we
at
have
the
to know,
beginning.
very good, because we need to know the retirement goal first. How much he needs at retirement
Right.
to support the annuity of 150,000 for how long again? For
20 years. So you just multiply that, right?
So that's the first step. Do you agree?
Yes.
Now, between year 0 through year 20, what's the interest rate?
6%.
6%.
Mm-hmm.
And during retirement, what's the interest rate? I think it's 8%.
8%.
That's also important.
Yes.
So that you're right, the first step here is to know how much is needed at retirement to support the annuity of 150,000 for 20 periods, right? So that's step number one. Right, so step number one amount needed at retirement, of course, to support the 20-year annuity of 150K, right?
Yep,
You know what that amount is?
3 million.
Mm,
What, because you're talking about interest?
That's right.
Oh.
So it's a present value of an annuity. Right? It is the present value of the annuity. Present value of the annuity. But we know what the annuity is. It's 150,000 times the present value interest factor annuity, which is 1, minus 1 over, what is the rate again? 8%. Raised to the power 20, because we have 20, it's a 20 period annuity, right? Over 1 week. And then, of course, if you used your calculator, then you could get that, that value, right? So again, what is N? 20 for N. 8 for I. 150 for PMT. 0 for future value, and then I compute the present value.
Oh, 1,000,000 for something.
And then I believe the answer here is going to be,
15049.
that's right.
722.
I believe the answer is 1,472,722, right? So it's 1,472,722.11. That's how much you need at retirement to be able to enjoy that stream of 150,000 per year for 20 years. Now,
That's not bad.
your goal is to save up enough to reach that amount, right? So now, we know that we need here 1,472,000 and 722.11. We know that to support this annuity. So therefore, step number 2, what must be the PMT so that we reach that amount, right? That becomes a future value problem. Do you see this?
Yep.
So that's
How much do I need to deposit? For how long? 20 years, so as to save up what? This much. Isn't that a future value now?
right.
Because this is not what I need to accumulate, right? So I'm looking for PMT so as to accumulate 1.472 million, right? In 20 years. So you have a question, go ahead.
So is this an annuity or annuity?
Well, the way it's set up, which one is it?
To calculate how much he should set aside.
Well, but the way it's set up. Is it the ordinary annuity or the annuity due?
Ordinary,
It's the ordinary, right?
yes.
But here, what's important is you need to know that now the second half of the problem is really a future value problem.
It's like 2 problems in one.
That's right.
Is it worth more points?
That's why I like it. Right. Do you understand why I like it? Good. Now, I know that 1,472,722.11 is the future value, right? And then I solve for payment so that the future value of the annuity will give me this number, right?
This is a future value, 1,472,000.
That's right. In the second half of the problem, it is a future value. Why? Because you gotta remember, you want to accumulate this much by making what deposits? It is a future value. But you have to start with the retirement goal first, which is the present value of the stream that you are going to receive during retirement. To know exactly how much you need saved up, right? And once you know that amount, well, how much what are the deposits that I need to make to reach that amount? That's really what the question is. So it's PMT times 1.06
Six,
raised to the power
20,
20 minus 1 over
six.
0.06. I used the equation for a future value of an annuity. And then I solve for
Payment.
payment. Does that make sense? I have a question for you. What if the uncle already had 15,000 saved up?
Then you just put that in as present value.
Very good. If the uncle already had 15,000 saved up, that would be in under present value. Why? Because the 15,000 would not be part of what? Of the annuity.
But we couldn't write it as such. We have to deduct it from the other side.
But you could also, I'll show you how to write it if it was the case. Because that, if that's the case, then I would say that my future value has two components.
Right.
It's going to be the future value of the annuity plus the future value of a single what? Cash flow. Do you understand this? For example, 15,000 times 1.06 raised to the power 20 plus the annuity part. I think we did something like that in class, didn't we?
We did something.
Right?
We did.
We did?
What's the answer?
Oh, so you just add that, you just say plus in the,
Exactly, plus. We take that, the annuity, that's the annuity part, plus 15,000 times 106 raised to the power 20. Right? Do you understand what I did? So you could write it.
right.
And then when you go to the calculator to solve, then your PMT must be, your PV, must be the, no. It would be the 15,000. If I said, if you had 15,000 saved up, then your PV will have to be 15,000. By the way, negative or positive?
Negative.
It would be negative, because as if it were itself a deposit, right?
Yeah.
Does that make sense? Are you okay with this?
What's the answer?
Well, and then the answer is
40,000,
40,000 and 3530, right?
Right.
Wasn't that a good problem?
It's a lot
Where
going
do you
on.
get 36.786 PMT?
What is that?
Where do you get the PMT amount?
Where?
36.786 on the resolution.
Yeah, but the 36.786, that's the future value interest factor annuity. But you don't really need to worry about that. It is really this term. Right? That's what it means, right? But do we really need to know that here? No. I mean, for the exam, you don't really have to give me that number, right?
Because you divide to get like that number.
Yeah, but once you write this equation, you could go ahead and solve for PMT. Because your question is, what is the 36.786? I'm telling you that the 36.786 is really this term right here,
If you solve for it.
right? But do you really need to go through that?
No.
Do you? No. Why? Because once you write this equation, you can solve directly for what?
PMT.
PMT. So let's not waste time. I mean, you would do this if you didn't have a financial calculator.
That means I will plug the number 1,472 as a future value.
Yeah.
Yes.
That's exactly, I think I didn't have, I thought I had it on the, no, I didn't have
No,
it?
you don't.
Okay, let me write it, okay, so the way you would do it is 24 for N, 6 for
Oh,
I, 0 for PV. 1,472,722, right? 111 for,
Future value.
and I compute what?
Empty.
PFT. That's it. I mean, then if you're doing this, then you don't need to look for this number, right?
Yeah.
I mean, if you want, you could, but then you will waste too much time. Valuable time, you know?
Yeah.
Next.
Prices of lower performing.
Actually, you could cancel this problem. We're not, because we didn't do that.
Okay.
35.
Cancel.
Yeah, 35, you could cancel that.
Good.
This says, your retirement account has a current balance of $50,000.
Gee, that's almost what I just said.
Right.
Yeah, keep going.
This question?
Yeah, yeah.
Okay. What interest rate do you need to be earned in order to accumulate a total of $1 million in 30 years that adding $6,000 annually should flow?
I think we did this one in class, right?
Yeah.
Yes,
So do you want to do it?
No.
No.
it's the same question.
It's the same question. That's what we did. I don't know if you remember.
Yeah.
Or if you want, I can do it again.
No.
You want me to do it again? No. 37. Erica, can you read?
Your car loan requires payments of $200 per month for the first year and payments of $400 per month during the second and final year. The annual interest rate is 12% and payments begin in 1 month. What is the present value?
So here we have two annuities, right? One of 200 and then the other one of 400. Now, if you were to show your work on this one, this is how you would do it. Do you want me to show you a timeline on this? The
Sure.
Timeline, very helpful.
Sure.
Remember, the timeline can also help you get the answer on the financial calculator. Right? 0, 1, 2, all the way to 12. And then 13, 14, all the way to what? All the way to 24. And then the first annuity is 200. So it's 200, 200, 200, 200, right? And then 200. And then the, actually, no, up to 12, sorry. And then after that, it's 400, 400, all the way to what? 24. Now, if you were to show your work, then you would say, well, the present value is going to be first the PV of this first annuity, right? Which is 200 times 1 minus 1 over 1 point, what is the rate?
12%.
Well, it's really 1%.
Yes.
Why? Because again,
It's
remember
1
that it's
year.
12% per year.
Yes.
I told you, when you're given a rate, unless it specifies that it is really per month, then you have to treat that rate as what? As being
Annual.
an annual rate.
Yep.
Right? So
Yep.
therefore, it's really 1%.
Oh.
Raised to the power 12. So that's for the first annuity, right? And then we need to add the second annuity, right? Which is 400. Do you agree? Times, by the way, even the 400 annuities for also 12 periods, right? So it's 1 minus 1 over 1 over 1 raised to the power 12 over 0.1. Except that here we have to make some adjustments. You know why? Because that annuity starts in 12 months, right? And since we're interested in the present value, we have to discount it 12 period. But not the first one, because the first one starts to that, right? So then I multiply to account for the fact that that second annuity starts in 12 periods. 1 over 1 over 1 raised to the power what? 12. That's how you would show your work. Do you understand why I did this?
Mm-hmm.
Because it starts in 12 months, right? Now, to actually get the answer, you could use a cash flow register. That's much easier. You know why? Because then if you go to your cash flow register, because of my timeline, what is my CF naught? It's gotta be 0. I have nothing in here, 0, right? What is my CO1? 200. With what frequency? 12. See that?
Mm-hmm.
What is my CO2? 400. With what frequency? 12. What is my interest rate? My I? 1, right? And then I compute NPV. That will give you, actually this one will be this will be the fastest way of getting the answer, right? So what's the answer?
Wait, for interest, you put, what did you put there? Under I?
It's 1. Isn't it? Isn't the interest rate 1? It is, right?
Oh,
Look.
per month.
Yeah,
Okay, okay. Yeah.
it is, right?
Because you divide 12 over 12. That's
Mhm.
why you get 1%.
What is that?
You divide 12 by 12.
12 by 12, yeah. Do you understand that? So what do you get?
6, 4, 6.
You get 6,246, is that correct?
Yes, 3, 3, 9, 4, 5.
I don't know. Which one is it? Right. I think it's 6,246.44.
Mhm.
Is that what you got? You don't get it?
I don't know how to do this, I must have missed that.
Shoot. Nope, F2 is
So you go to the cash flow. First you have to
enter,
clear the register.
and no,
Right?
clear,
CF naught is
No.
nothing. So
One.
you go to the next one.
I,
It's 200.
and then compute.
Frequency of 12.
I definitely didn't get that right.
Frequency of what?
37? No, that's not right.
This will be done, right? And then NPV, enter the rate, which is 1. Go down, compute.
200, enter 1200, 400.
See that?
Okay.
Can you write an equation for the future value in which we have to compound the first payment,
1,
12 periods?
1, I.
Yeah, it's possible.
Because then I can take both answers and I can just discount them. I
I'm
mean,
not getting it.
discount one
Mm.
or
It'll-
compound the other
No.
and get to the other
Maybe you
answer.
just miss the
They should
interest
both be the
rate.
same answer when I put them in the
Put in
same.
one.
1%.
That's what I put in.
Just so I can see how, I didn't catch that.
You put
That
just
you were
one
discounted
not.
at 12 years
Yeah, that's what I
initially.
did.
Do
I
it
just
again.
caught that right now.
So why did I discount here?
Oh, I know why now, but I
Okay.
never caught that before in class.
And then,
So I'm saying, can you do the future value such that
You could do
the
that.
first payment has to be compounded 12 periods?
Yeah, you could do that. For example, this, you could do the, but even then, you have to be careful, right, when you do a future value. You have to
So
be-
what I'm asking you, if you'll write it out for me.
How would write this? For
Yeah, the future value, right.
Like in this
Equation.
form?
Yeah, exactly.
I'm not getting that either when you're done. It's not coming up.
Oh, really? You're
Yeah,
not getting
sorry.
the answer?
Sorry to interrupt. Fine.
But are you getting the answer? No?
I didn't. I don't know what I did wrong. Sorry.
Oops, sorry. Oh, sorry.
That's okay.